Hello, in this lecture, we're going to start with limits, continuity, and differentiability. And again, an important topic for JEE Advanced and mains examinations for all those who are doing the preparing for JEE Advanced and mathematics. This is the lecture on limits and continuity. And we're going to do all these things as we go along. And it's going to be quite descriptive sort of lecture. But today, just let me share the screen. We are going to start with limits. Okay. Okay. So what are limits in general? So what is concept of limits? For example, you are given a function fx equals to x square minus 4 upon x minus 2. And you can clearly see that as at x equal to 2, you have fx uh, is an indeterminate. Is indeterminate. Why it is indeterminate? Because it attains a okay. So we are starting with concepts of limits, and let us say that your function is defined as x square minus 4 upon x minus 2, and you know that x is not equal to, because if x equals to 2, then this will become a 0 by 0 form. Am I audible? समझ में आ रही है? ठीक है. So it will get into an indeterminate form. So at all such places, one needs to find limits of the function. Okay, because you can clearly see that at x equal to 2, your function is not defined. So what would be asked? It would be asked that what is the tendency, and this particular word now you're going to use. You're going to see in entirely your calculus course that this word I'm going to repeat time and again. That is tendency. That is, I'm interested in finding what is the tendency of function as x tends to 2. Okay, as x tends to 2, how would your function behave? This is my understanding. So one could actually go by calculator and start doing it like 2.01, 2.001, 2.0001, 2.00001, and all those things, and you can place it here, and you will find that as you are getting closer to 2, you will be getting closer to 4. And why 4? Let us see. So for example, one thing one needs to understand is whenever I say that I'm dividing 6 by 3, I mean 2. Why do I mean 2? Because I can group my 6 numbers. It says that can you group it into 3 groups, like group of 3. So I can make a group of 3 and there can be 2 groups. So I can clearly see that 3 as a you can cut 6 as a fact, like 3 times 2, but you cannot cut 0 by 0 form. Okay. Now there is a problem because if x equal to 2, it will become 0 by 0 form. So what one needs to do, one needs to go in a sufficiently small neighborhood of x equal. You cannot be at exactly x equal to 2, rather you will have to be on the neighborhood of x equal to 2. And what can be the two ways in order to approach x equal to 2? One can be towards right and other one towards the left. So let's say this is your 2. You can approach your 2 from the left hand side, and you can approach this x equals to 2 from the right hand side. What does it imply? It says that if I approach my 2 from the right hand side, that is, I am on the right hand side. Let us find what would be the limit. So limit h tends to 0. I'm on the right hand side. So it is 2 plus h ka whole square minus 4 divided by 2 plus h minus 2. Okay. And what I will get, I'll get 4h square plus 4h plus 4 minus 4 divided by h. So 4 gets cancelled. And here you have h plus 4. Now, initially what you were saying that you are close to 2, not exactly 2. So you are close to 2 and to the right hand. Okay. So to the right hand, you are close to 2. Okay. And what you're finding that the limiting value turns out to be 4 plus h. Now 4 is a very significantly large word as compared to h. H is infinitesimally small. Infinitesimally small समझते हो? जितना छोटे से छोटा चाहो उतना छोटे से छोटा. Let's say तुम्हारे लिए छोटा होता होगा 10 की पावर minus 9 meters. कोई कहेगा नहीं नहीं minus 10 की पावर 12. कोई कहेगा नहीं 10 की पावर minus 18. Some would say 10 की पावर minus 100. I'm saying as small as it may please to you, you can take h. So if you add h to 4, you will say simply 4. So this is the beauty of limits. Initially, you were saying that h is infinitesimally small. What you were saying h was infinitesimally small, and if I do it another manner, like let's say if I use this particular thing, x square minus 4 upon x minus 2, I can write, again I'm doing it for you, I can do it in this fashion also, because that will so I'll write x minus 2 into x plus 2 divided by x minus 2. देखो पहले पहले क्या कह रहे थे कि x 2 के बराबर नहीं हो सकता. क्यों नहीं हो सकता? Because if x is equal to 2, then I cannot cut it this fashion. Why I cannot cut it? Because 0 cannot be like I cannot cut in this fashion, because you see 6 को 3 से काट सकते हो. Why you can do so? Because 3 times 2 is 6, but 0 times what would give you 0, you don't know. So it is indeterminate. So what you do, you go towards the left hand side, so right hand side. So if I go towards right hand side, that is if x is equal to 2 plus h, then I can write this is h, this is 4 plus h, and this is h. So once you are saying that h is tending to 0, not exactly 0, you are saying acha okay, h is not exactly equal to 0, it is close to 0. So now you can cut. पहले नहीं काट पा रहे थे, जब मैं कह रहा था क्या x equal to 2 पे रख सकते, तो तुम कहोगे नहीं x equal to 2 नहीं रख सकते, क्योंकि 2 minus 2 is 0, 2 minus 2 is 0, you cannot cancel them out. But once you place 2 plus h, now you can say that h, no doubt it is very small, infinitesimally small, but you can now get rid of them. Because they're infinitesimally small, now you can get rid of them. Are you getting, Harshit? Is that clear?
Yes, sir.
Okay. Now, if they're infinitesimally small, not equivalent to 0, initially you told that they're not equivalent to 0, they're close to 0. Now, just one step later, you are saying, okay, what is the point of adding h to 4? It is very close to 0. So now you're saying 4. So this is beauty of mathematics. At one point, you are saying that it is infinitesimally small, not equal to 0, and that you are cancelling it as a factor, because you're saying, okay, h कुछ तो है 0 के पास, कितना पास, जितना पास उतना पास. So let's say 10 की power minus 18. So you can cancel out 10 की power minus 18 by 10 की power minus. But then on the next step, you are saying कि 10 की power minus 18 को 4 से क्या जोड़ना? So you'll say नहीं 4. Okay. So this is one of the beauty of, so one side you find that your function approaches 4, and similarly on the left hand side also, I'm leaving it to you as an exercise. You can find that this will also be 4 minus h, limiting value, it will give also 4. So first thing that one needs to understand, that if at all limit exists, then it must be unique. And by unique, I mean that tendencies should be unique. And tendencies unique mean that your right hand limit should be equal to your left hand limit. It cannot be the case that your left hand is a different limit and right hand is a different limit. So if at all you say that your limit exists and it is unique, then this tendencies must be unique. Is that clear, Harshit? ये चीज समझ में आ रही है? By which I mean that to the right hand side, your function should have the same limit. Let's say if I'm evaluating my limit at x, so let's say x plus h, and similarly you should have the tendency towards the left hand side. So now if this is a standard NCERT question. If you see your NCERT, this is what they start with. So this is what I have taken. So first thing is that the tendency should be unique. Now you will be thinking that what do I mean by tendency? So very abstractly I'll say, because this subject as you go along, as you do your graduation or something, even if you do your engineering, this will again be there. So you'll learn this subject in greater detail and with greater rigor. But right now, because we are in standard 12, you're just developing the subject. So let us keep it very simple. Okay, let us keep it very simple. And what do I mean by saying tendencies? The tendencies should be coinciding. They should be coinciding. It cannot be the case कि एक तरफ से आपकी tendency कुछ एक तरफ से आपकी tendency. Let's say yesterday also I gave you an example that let us take the example of greatest integer of x. And always remember, don't create a fuss about it. This is nothing but greatest integer less than or equal to x. What does that mean? Now, if I say, what is 5.4? Greatest integer of 5.4. What you have to do is just go below it. So you go below it 4, 5, 3, 2, 1, 0, minus 1, so and so forth. So 5.4, इसकी definition में इसका answer लिखा हुआ है, greatest integer less than or equal to x. So if it is integer, then तो जो दे रहा है वही. Let's say if I was saying 5, तब तो 5 के बराबर ही होगा, equal to x. और अगर नहीं है, then greatest integer less than x. So आप x की जगह यहाँ पर क्या 5.4, इससे आप नीचे जाएंगे, that is 5, 4, 3, 2, 1, 0, minus 1. And now the greatest integer among them is 5. So answer would be 5. Similarly, if I write minus 5.4, what would be the answer, Harshit?
The -6, yeah.
Okay. Why -6? Because all you have to do is just go below. So if you go below, you will get -6, -7, -8, so on and so forth. Greatest among them is -6. So this is how you define greatest integer function. So what would be greatest integer? 0 to 1. So from 0 to 1, you can clearly see that your greatest integer would be 0. At 1, you cannot define it. Exactly at 1, you'll find that your function jumps at 1. And at exactly at 2, again function jumps at 2. Exactly at 3, your function again jumps at 3, and so on and so forth. So from 0 to 1, your greatest integer would be what? So if x lies between 0 and 1, your greatest integer x would be 0. If x lies between 1 and 2, then your greatest integer would be what? 1, and so on and so forth. Is that clear? Now you take any of these integers. You take any of these integers. So for example, if you take any of these integers, let's say I'm taking any of the integers. So n belongs to z if I take. And if I want to find the tendencies of the limiting behavior for the function greatest integer x at the integer, what it would be. So let's say I want to evaluate my limiting behavior, right hand tendency of greatest integer to the right of an integer, that is n plus h. So what would be n plus h? So again, n plus h is some number. इससे नीचे जाओगे, सबसे पहले कौन सा इंटीजर मिलेगा? n. उससे नीचे n minus 2, n minus 3, n minus 3, and so on. So greatest क्या है? n. So what would be the right hand tendency? It would be n. But if I इतना भी छोटा चला गया, मैं समझ रहा हूँ, थोड़ा सा भी, हल्का सा भी, n minus h, even if it is just minus h, even if it is infinitesimally small, your greatest integer would now be n minus. Why? Because let's say this is your n, this is n plus h, and this is n minus h, and this is n minus 1, and this is n. Now you can clearly see that if I want to write greatest integer less than or equal to n minus h, so n minus h से greatest integer less than or equal to x होगा, n minus h से नीचे जाओ, जो सबसे greatest integer दिख रहा है वो क्या दिख रहा है इन सब? n minus 1. Is that clear or not?
Yes, sir.
Bharat has joined. Bharat, is that clear or not?
Yes, sir.
Okay, so this is the left hand tendency and this is the right hand tendencies. So you can see here that your right hand and left hand tendencies are no doubt finite, but they don't coincide. They don't coincide. Is that clear? So such things, in such scenarios, you write limits. Limit does not exist. Is that clear?
Yes.
So one of the limits I would write here is one of the limit. So okay. So now there can be many things. One of the limits, let's try to evaluate. Second of the limits, let us evaluate, and let's say that is limit x tends to 0, 1 over x. And one needs to find what would the limiting behavior. So let me plot a graph for it. So as I know, as x tends to 0, this will go towards infinity. As x tends to infinity, this would go to 0. As x tends to 0 minus this particular limit would go towards minus infinity. So you can see that as x tends to 0, to the right, you are going towards infinity, and to the left, you're going towards minus infinity. These tendencies are infinite. So one must admit that limits can be infinite also. Okay, so there are sometimes doubt. People say that a limit will not exist. No, limit exists. Towards the right, that is plus infinity, and towards the left, minus infinity. However, here the limits, the tendencies are not unique. So one needs to admit that tendencies can be even infinitely large. It can be infinitely large, but here I would say that limit won't exist because again the left hand tendency is not equal to the right hand tendency. Is that clear?
Yes, sir.
Okay, so you should get do away with the perception that limit has to be a finite number. It can be an infinite number. Like it can go towards infinity. Okay, so limiting behavior can be very large as well. And what is infinity? Infinity is nothing, but it is used to explain that as x tends to 0, your 1 over x can be as large as possible. It can be as large as possible. So it actually indicates a number as large as you may think. As large as you may think means, let's say, again, all these kinds of things are quite you can say relative terms. Let's say if I say x tends to 0, so it is a very relative term. Why it is a relative term? Let's say you were sitting in Newton's time and it was 16th century. And if you go even to the, like, I'm not saying to the Newton because Newton is the father of calculus. So he will be talking always of infinitesimal small quantities. Okay. So he has that kind of perception. But if you go in Newton's time and go and tell him, okay, there's something called as nanoscience, okay, or there's something called as 10 to the power minus 9 meters, so he will be very angry upon you. He will be very angry upon you. He may get infuriated, or probably he may think that you are a fool to say this. But now, sitting in 21st century, you know that there are Fermi meters, and there is a lot more amount of physics that's going on there. Okay, so 10 to the power minus 9 meters is around 1 nanoscale. So you know that there are nanomaterials, there are nanotechnology, everything is running over it. Okay, so all these terms are quite relative as such. So for infinity, let's say if you have a point charge here, 1 coulomb point charge, probably this is an infinite for it. Okay, so where its effect is going to get nullified, that would be infinite. But for an astronomer, the infinity perception would be as large as possible. For an astronomer, it can be the diameter of a visible universe. Okay, so for him, it can be as large as that possibility. Is that clear to you? So infinity and all these things, kind of concepts, are very abstract concepts, and one needs to understand that these are all relative concepts in order to explain very large numbers and very small tendencies. So for example, if I say x tends to 0, so for example, for a person who is working in a sabji mandi, and if he's going with a truck, a loss of a mango from his truck is not going to bother him. Okay, so it is a very small loss. But itna hi gold kisi ka gir jaye, and if it's a goldsmith, it is going to matter much to him. So understand the point. All these things that I'm saying are relative terms. Okay, all these things are very relative. In mathematics, all these things cannot be accounted for, and mathematics always says that be precise. And therefore, when you'll be studying this subject in greater detail, this would be called as real analysis as you go along. But right now, I'll not go there. But let us just try to understand one of the definitions that are quite fundamental, and that is called as epsilon del definition for limits. Just giving you a hint of what your life would be if you go all along. But it's not going to be asked in your exam anyway. But just pay attention to this. So whenever I say limit x tends to a, f of x is L, what does it imply? Always remember, whenever I say modulus, so modulus के दो मतलब होते हैं. पहला मतलब तो ठीक है, तुम कह रहे हो absolute value of a number. दूसरा, also understand it represents the distance of x from 0. Okay, and since you are studying in standard terms, so I'll only stuck to the Euclidean sort of distances. So what does it represent? It represents the distance of x from 0. Is that clear? अगर तुमने complex पढ़ा होगा, तो जब भी कभी complex number पढ़ते हैं, तो you know that x plus iota y, so you write x comma y. And if I say what is modulus z, so instantly you will tell this is x square plus y square. You instantly tell me this. Is that clear? So अगर तुमने complex number पढ़ा है, तो z का mod क्या कहलाता है? याद करो, root over x square plus y square. Is that clear? याद है थोड़ा सा? Harshit, is that clear?
Yes.
Okay. And what does root over x square plus y square would represent? This is x minus 0 का square, y minus 0 का square का root over. तो क्या distance नहीं represent कर रहा? X comma y की 0 comma 0. Is that clear? So one of the perception that you need to know right now start building is that modulus not only represents an absolute value of a number, but in metric sense, it also gives you a distance. Is that clear? Okay. So what does limit mean? So limit says that x is tending to a. X is tending to a मतलब x a के करीब जा रहा है. So you will say x minus a का modulus can be made as small as possible. समझ में आई मेरी बात? केवस का मतलब x tends to a मतलब x और a का जो distance है can be made as small as possible. Is that clear?
Yes, sir.
Okay. And when you are taking this distance as small as possible, your fx and distance of fx with L can also be made as small as possible. Is that clear? So maths में ये as small as possible ऐसे terms नहीं चलते हैं. That is what I was saying. These are all relative terms in maths. So what mathematicians have done, they have written a definition called as epsilon del definition to limits and continuity, and you'll see as you go along all these kind of definition you are going to see. The definition says that given epsilon greater than 0, epsilon means it will set a tolerance limit. अभी समझने की कोशिश करना, tolerance limit या error limit. It will set a bar. कैसा बार? If I want to make fx minus L का distance as small as possible, तो epsilon यहाँ पे क्या है? जितना छोटे से छोटा लेना चाहो उतने छोटे से छोटा. Is that clear? तो question हम क्या बोल रहे हैं? fx minus L का distance as small as possible किया जा सकता है कि जितना छोटे से छोटा किया जा सके, मतलब I can write it as epsilon. Is that clear? whenever x माइनस a का डिस्टेंस भी छोटा किया जा सके उसको बोलते तो डेल। और ग्रेटर देन 0 क्यों लिख रहा हूँ बेटा? इसलिए लिख रहा हूँ क्योंकि x हो सकता है a पे डिफाइंड ही ना हो। x हो सकता है a पे डिफाइंड ही ना हो। जैसे एग्जांपल ये था, हम लोग अभी थोड़ी देर पहले एग्जांपल कर रहे थे, लिमिट x टेंड्स टू 2, तो देखो x इक्वल टू 2 पे फंक्शन डिफाइंड ही नहीं है। तो x माइनस 2 का x और 2 का डिस्टेंस हमेशा किससे बड़ा हो? 0 से बड़ा हो और डेल से छोटा हो। तो अब इसको समझने की कोशिश करते हैं। अगर ऐसा है, if this is the condition that for a given epsilon you can produce a del, मतलब मैं कहने की कोशिश ये कर रहा हूँ कि अगर ऐसा तुम कर पा रहे हो कि जब जब भी तुम कह रहे हो क्या fx और l का डिस्टेंस एप्सिलॉन से छोटा किया जा सकता है, लेट्स से अर्शित ने कहा क्या फंक्शन और l का डिस्टेंस एप्सिलॉन से छोटा किया जा सकता है, ऐसा तुमने मुझसे पूछा, तो सुदीप कह रहा है यस इट कैन बी डन अगर x और a का डिस्टेंस इससे छोटा है। हर बार जब तुम मुझे एप्सिलॉन दे रहे हो, हर बार मैं तुम्हें अगर डेल दे दूं, इसका मतलब आई एम सेइंग जितना तुम एल के करीब जाना चाह रहे हो उतना जा सकते हो, प्रोवाइडेड मैं जितना एक्स को ए के करीब ले जाना चाहूँ उतना। दिस इज समटाइम्स रेफर्ड टू एज एप्सिलॉन डेल डेफिनेशन। लेट्स से गिवन योर क्वेश्चन होगी, लेट्स से योर क्वेश्चन वाज fx is equal to x square minus 4 divided by x minus 2 x not equal to 2. Now somehow you know that the limit to this function was 4. हर्षित इज दैट क्लियर? कहीं पे भी को प्लीज पूछ लेना मुझसे, कहीं पर बेट को प्लीज पूछ लेना।
Yes.
ये समझ ठीक है? अब हर्षित तुम्हें पता है इसकी लिमिट क्या है, थोड़ा सा एक आइडिया है ही। तुम कह रहे हो क्या -4 फंक्शन और 4 के डिस्टेंस क्या 0.1 से की जा सकती है? तो तुमने मुझे एप्सिलॉन क्या दिया बेटा? 0.1। अब जो मेरी डेफिनेशन उसके हिसाब से यू गिव मी एन एप्सिलॉन, so given epsilon you give me an epsilon if I'm in a position to give you a del, and this del would again depend upon epsilon only. अगर ऐसा कर पा रहा हूं इसका मतलब तुम जितना छोटे से छोटा एप्सिलॉन लेना चाहो उसके कॉरस्पॉन्डिंग उतने छोटा डेल ले लिया, डेल आ जाए। और डेल क्या है बेटा? एक्स और ए की डिस्टेंस है। तो कहने का तात्पर्य ये हुआ कि एफ एक्स और एल का डिस्टेंस जितना छोटे से छोटा लेना चाहे उतना छोटे से छोटा ले सकते हैं। कब? whenever x माइनस ए का डिस्टेंस जितना छोटे से छोटा होना चाहिए उतने छोटे से छोटा हो जाए। सो अगर इस स्थिति में हो हर बार, every time that you give me an epsilon, if I'm in a position to reciprocate you back a del, it itself implies that limit x tends to a, fx is equal to l. Is that clear? This is sometimes referred to as epsilon del definition for limits. However, it is not in your JEE standard course, but still I have taught you for your future thing. So let us try to execute it. तुमने मुझे कहा इसकी डिस्टेंस, इसका लिमिट 4 है, इसका 4 है लिमिट, इस फंक्शन का लिमिट 4 है एज एक्स टेंड्स टू 2। तो तुमने कहा fx माइनस 4 का डिस्टेंस क्या 0.1 से छोटा हो सकता है? So, अभी एप्सिलॉन की जगह क्या है बेटा? 0.1। इज दैट क्लियर?
Yes, sir.
और x 2 के बराबर नहीं है तो नाउ यू कैन कैंसिल इट ऑफ एंड इट विल बी x प्लस 2। इज दैट क्लियर? अगर x 2 के बराबर
Yes.
होता देन x प्लस 2 मतलब x माइनस 2 का मॉड किससे छोटा हो जाए? 0.1 से।
Yes, sir.
इसका मतलब क्या हुआ? अगर मैं राइट हैंड साइड पे रहूं, अगर मैं राइट हैंड साइड की बात करूं तो x माइनस 2 का मॉड किससे बड़ा हो जाए, किससे छोटा हो जाए? 0.1 से। और यहां से भी मैं कह देता हूं इधर भी आ जाएगा -0.1, यहाँ पे लिख दूंगा एक्सेप्ट x इक्वल टू 2, मतलब x माइनस 2 0 नहीं होना चाहिए, उसके अलावा सारे पॉइंट्स क्योंकि x ठीक है, क्योंकि x इक्वल टू 2 पे फंक्शन डिफाइंड। इज दैट क्लियर? इसका मतलब x किसके
Yes.
बीच में? 2.1 से लेकर -1.9 के बीच में। Is that clear? However, understand I'm writing that x minus 2 cannot be equal to 0. वो याद रखो, ठीक है? Is that clear? मतलब इसके बीच में x equal to 2 आएगा कहीं ना कहीं, I'm saying उसको मत लेना because that is not allowed. Is that clear?
Yes.
और इसी चीज को लिखने में तुम क्या लिख सकते हो? ग्रेटर देन 0, यहाँ से ग्रेटर देन 0 भी कर सकते हो इसी चीज को। बट आई डोंट वांट टू डू इट राइट। ऐसा समझना ही मेरी बात। या फिर इसी चीज को तुम सोचो, क्या मैं ऐसा लिख सकता हूँ x माइनस 2 का मॉड शुड ऑल्सो बी लेस देन 0.1, क्योंकि अगर तुम -2 यहाँ लेते हो तो x माइनस 2 का मॉड शुड बी लेस देन 0.1। यही हुआ इसका मतलब? इसका मतलब फॉर योर गिवन एप्सिलॉन आई एम इन अ पोजीशन टू गिव यू डेल। तो तुम्हारा एप्सिलॉन भी 0.1 है यहाँ पे और कोइंसिडेंटली यहाँ डेल भी 0.1। अब तुम मुझे एप्सिलॉन दे दोगे 0.01 तो योर डेल वुड बी व्हाट? 0.0। You will say your epsilon is 10 की power -14. I'll say my del is equal to 10 की power -14. So you give me an epsilon and I will give you a del. ठीक है? So इस तरीके की अगर हर बार टेंडेंसी मतलब हर बार तुम जितना पास जाना चाहो उतने पास जा पा रहे हो। कौन? फंक्शन और लिमिट के डिस्टेंस को जितना छोटे से छोटा लेना चाहो उतने से छोटा छोटा ले पा रहे हो। कब? जब x और a का डिस्टेंस जितना छोटे से छोटा होना चाहिए उतने छोटे छोटा हो जाए। इज दैट क्लियर? मतलब समझ
Yes,
पा
sir.
रहे? fx minus L can be made as small as possible whenever x minus a ka mod can be made as small as possible. This as small as possible is now quantified by using epsilon del. So you give me an epsilon and I'll give you a del. You give me an epsilon, I'll give you a del. If I am in this process, for every given epsilon, if I'm in a position to reciprocate back a del, then I would say that limit x tends to a, f of x would be L in this scenario. Is that clear or not clear? भरत को समझ में आया नहीं आया?
Yes, sir.
Is there any doubt?
सर ऐसा
हाँ बोलो.
सर ये डाउट था कि एप्सिलॉन और डेल जैसे डिफरेंस भी हो सकते हैं ना, जैसे इस वाले केस में तो सेम है.
हाँ बिल्कुल बिल्कुल different हो सकता है. But understand that del would be a function of epsilon. मतलब del would indeed depend upon epsilon.
यस
Okay,
सर.
so that would, I would take any day along, but overall understand कि ये ऐसा होगा. It may be different also. It may be it can be different also. Right now, coincidentally, the function that we took happened to be like where your epsilon del are equal. Is that clear?
यस सर.
Okay. Chalo ji. So now because your JEE course suggests me that you are more or less therefore. So first thing. It's quite mechanical course as such, but let me start with writing these things. So one of the limits is given by limit x tends to 0, sin x over x is equal to limit x tends to 0, tangent x over x, and limit x tends to 0, x upon sin x, and limit x tends to 0, tangent x upon tangent x. All these limiting values are equal to 1. Is that clear? Is that clear? Harshit, is that clear?
Yes.
Okay. Now, चलो अभी यहीं से अपन क्वेश्चन चालू करते हैं, so that things will become more clear to you. ठीक है? मुझे क्वेश्चन का जवाब दोगे? Question number 1. What do you think that limit x tends to 0, greatest integer sin x over x would be? And similarly, I'm asking, what would be the limit x tends to 0, greatest integer x upon sin x would be? हर्षित क्वेश्चन तो समझ में है. अभी तुम sin x upon x सिंपली कर रहे थे, अब यहाँ ग्रेटेस्ट इंटीजर, और याद रखना ग्रेटेस्ट इंटीजर बाल की खाल में निकाल देगा. बाल की खाल निकालना तो समझते हो, मतलब तुम इसमें 1 से थोड़े से इधर हुए तो 0 कर देगा लेफ्ट हैंड में, और थोड़े से राइट हैंड में गए तो 1 कर देगा. तो चलो इसको समझते हैं, तो कैसे करोगे. सो मैं यहाँ लिख रहा हूँ इन प्रिंसिपल ऑलवेज रिमेंबर, and this inequality we are going to derive in differential calculus as we go along. But right now, just remember, in principle, always remember that your sin x is always less than x. Sin x is always less than x, and x is always less than tangent x. Is that clear? Is that clear? Harsh, is that clear or not clear? This property we are going to derive because much of these properties have their roots in classical geometry, and probably I may derive one of them as I go along. But right now, just remember that in principle, for all x, I'll write 0 to pi by 2. This is the case. मतलब समझ में आया नहीं आया इस बात? But this is you can take as a statement right now. Is that clear? Harshit की आवाज नहीं. Harshit, is that clear?
Yes, sir. Yes, sir.
Okay. So in principle, always remember that x, and I'll derive this property probably tomorrow, so that it will be clear for you also. But overall, understand that this is always true. This is always true. Okay. Since this is always true, so always remember that your sin x by x will always be less than 1, and x by sin x will always be greater than 1. So now you would say What about limiting behavior? No doubt limiting behavior will be close to zero. Limiting behavior will be close to zero, but this limiting behavior would be less than one. That is, this limiting behavior would indicate that is this is certainly tending to one. I'm just saying in the limit. In the limit x tends to zero. That is the limiting behavior of sin x by x would be no doubt one only, but it would be one minus something because this is one towards. Are you getting my point? That is sin x by x would be less than one. In principle, always remember this is the truth. And there is a classical geometrical derivation to it. I just don't want to right now focus on that because that will disturb the tone of our entire process. Right now I want to rush very fast so that at least to make one limits lena seek job, and then as we go along, once that aptitude comes on, then I'll do all these kind of proofs also for you. Is that clear, Harshit? So in principle,
Yes, sir.
sin x by x would be less than one. लेस देन वन का मतलब समझ रहे हो? नो डाउट इसकी लिमिटिंग वैल्यू वन के पास जाएगी, बट वन के कितना पास? वन माइनस समथिंग रहेगी. इज दैट क्लियर? एंड x by sin x would be greater than 1. That implies इसकी जो लिमिट आएगी बेटा, आएगी नो डाउट वन ही, लेकिन इट विल बी टुवर्ड्स द राइट ऑफ वन. इज दैट क्लियर? Harshit, is that clear? So now if I say what would be limit x tends to 0, greatest integer sin x upon x. So what will be your answer? 0. Why 0? Because anyway limit x tends to 0. I'm again saying अगर यहाँ पे greatest integer नहीं लगाते, if there was no greatest integer as such, तब क्या होता? तब आंसर बन ही क्या? Because now greatest integer is there, now it will take care. Now it will say okay कितना पास 1 के, how much close to 1. Now you would say okay it is close to 1, but it is 1, it is close to 1 but on the left hand side. So on the left hand side means you are trying to find limit h tends to 0, 1 minus h, and 1 minus h greatest integer would be 0. Is that clear?
Yes, sir.
And similarly, limit h tends to 0. If I ask you what would be greatest integer of x by sin x, answer would be 1. Is that clear?
Yeah.
Okay.
Yes, sir.
Okay. That is good. So one of the अच्छा चलो second question. भरत को समझ में आ गया?
Yes, sir.
Okay. And mostly like Bharat, this would be mostly like class on JEE kind of thing, ना? So यहाँ पे क्या होगा कि बच्चों को they are more related to मतलब solving part. मतलब in standard 12 we are concerned with more with solving things. Okay. So
Yes, sir. It's good, sir. No problem.
Okay. चलो. So just try to find me the limit this. Just try to find limit x tends to pi by 2 plus secant inverse of sin x. Harshit, what do you think the limit would be? Okay, so let me do this for you. अच्छा पहले ही सब अच्छा एक बात.
1 second, sir.
अच्छा, you are trying to do?
Yes.
Okay, so what do you think an answer would be? Okay, and that
So is
one
it
thing.
pi?
हाँ जी बेटा,
पाई बाय 2 है क्या सर?
pi by 2. Okay, okay. So let me try. So होगा क्या? One needs to understand that we'll go towards both of the sides. Okay, so we'll go both of the side, left hand limit and right hand limit. ठीक है? तुम्हारे हिसाब से मैं बोल रहा हूँ. Let's say you are fighting for any exam. Let's say JEE Advanced or JEE Mains or whatever. Always remember, हालांकि मैंने ऑप्शन नहीं दिया, अगर ऑप्शन दिया जाए and one of the options says limit does not exist, it implies one has to see the limiting values on both of the sides. That is to the right and to the left. हमेशा याद रखना, ये गलती नहीं करना एग्जाम, ठीक है? चलो सबसे पहले काम करते हैं, पहले एक बार देखते हैं कि पाई बाय 2 पे क्या होगा. तो आई एम जस्ट राइटिंग एट x इक्वल टू पाई बाय 2. x इक्वल टू पाई बाय 2 कितना होगा बेटा? सेकंड इनवर्स 1. ठीक है, साइन पाई बाय 2 कितना होता है 1, और सेकंड इनवर्स 1 कितना हो जाएगा 0. याद करो, secant 0 is 1, and you remember this now, secant inverse is not 1 upon secant x, no, it is not equal to 1 upon secant x. I hope you remember this. I mean, this is trigonometric, inverse trigonometric function. That is, it wants to find the inverse value for a, you want to find an angle for a given value. Is that clear?
Yes, sir.
Bharat, is that clear? Bharat, sorry, Harshit, is that clear?
Yes, sir, yes, sir.
ओके, सो यहाँ तो कंफ्यूजन नहीं है ना, ये तो आता है इनवर्स ट्रिग्नोमेट्री. इनवर्स ट्रिग्नोमेट्री में क्या कर रहे हो? व्हेनेवर यू आर सीइंग सेकंड इनवर्स x और फॉर एग्जांपल cos इनवर्स x, you are interested in finding the angle for which that corresponding value is there. So for example, if I say what would be cos inverse 1 by 2, so you want to find that angle whose cosine would give you half. Is that clear? So it's not 1 upon cos, it is cos inverse. अच्छा ठीक है. So now let us take x tends to pi by 2 वाला case. So x tends to pi by 2 means what? X tends to pi by 2 means चाहे left hand लो चाहे right hand लो, whichever case you want to find, because you know that for left hand also and right hand also, sin pi by 2 minus hp cosine h होता है, और sin pi by 2 plus hp cosine h होता है. Are you getting my point? मतलब चाहे तुम sin pi by 2 plus h लिखो, चाहे sin pi by 2 minus h लिखो, they are one and the same thing. They are both cosine h only. Is that clear?
Yes, sir.
Okay बेटा, अब देखो, let us try to write this. h tends to 0. अगर पूरे पे लिखे तो secant inverse cosine h ऐसे लिख सकते हो. Okay, and if you have taken your classes on trigonometry, you know that your cosine h would be less than minus, it will always lie between -1 and +1. And even if it is tending to 0, तो जैसे देखो cos 0 पे 1 होता है, cos 0 पे क्या होता है बेटा? 1. Exactly at cos, exactly at x equal to 0, cos would be 1. But जैसे ही if you deviate from 0, your value would be less than 1 strictly. So your cosine x would be strictly less than 1 for all x greater than 0 and less than pi by 2. तो यहाँ पे वैल्यू क्या होगी? लेस देन 1. मानते हो मेरी बात? एग्जैक्टली 0 पे cos की वैल्यू क्या होगी बेटा? 1. अदरवाइज cos h, h मतलब क्या है? 0 से थोड़ा इधर गया, 0 से थोड़ा इधर गया, तो देखो मैंने पर्पल में बनाया, यू कैन सी दैट योर वैल्यू ऑफ cos h would be less than 1. Is that clear?
Yes.
Okay. Now just pay attention to secant x. So what is secant x? It is 1 upon cosine x. And always remember that your cosine x would lie between -1 and +1. Cosine x would always lie between -1 and +1. And that gives you that your secant x would always be greater than equal to 1. So it cannot be less than 1. So if secant x cannot take any value less than 1, what will be answer to this? Answer would be not defined. Why not defined? Because cosine h would be what? Less than 1. And now you are interested in finding the secant inverse of a value which is less than 1, which cannot be possible, because you know that your secant will always give you a value which is greater than 1. So it cannot give you an angle corresponding to a value which is less than 1. Is that clear or not? मैं हिंदी बोलूं, कोसाइन एच बेटा क्या होता है? कोसाइन एच हमेशा 1 से छोटा होगा. देखो हाँ, आंखों से देखो, cos 0 पे क्या हो रही है? वैल्यू 1. और जैसे तुम आगे जा रहे हो 0 प्लस कर रहे हो, वैसे कोसाइन एक्स क्या होगा? लेस देन 1 होगा. इसका मतलब ये जो क्वांटिटी लिखी ना अंदर, ये लेस देन 1 है. अगर कोई लेस देन 1 क्वांटिटी है, उसके कोरस्पॉन्डिंग सेकंड इनवर्स कभी भी कोई एंगल दे सकता है कि नहीं? क्योंकि सेकंड एक्स हमेशा ग्रेटर देन 1 होता है, ग्रेटर देन इक्वल टू 1 होता है. तो सेकंड एक्स की हमेशा वैल्यूज हमेशा क्या आएंगी? ग्रेटर देन और इक्वल टू. तो सेकंड एक्स की वैल्यू हमेशा क्या आएंगी? ग्रेटर देन इक्वल टू 1. तो सेकंड इनवर्स ऑफ अ क्वांटिटी व्हिच इज लेस देन 1 will never be different. Why? Because secant x can never can never lie between secant x can never lie between 1 and -1. जब वो 1 और -1 के बीच में हो ही नहीं सकता तो कोई भी वैल्यू का एंगल वो कैसे रिटर्न करेगा जो -1 से 1 के बीच में. मेरी बात समझ पा रहे हो हर्षित? इज दैट क्लियर?
हाँ सर.
पक्का 100%?
हाँ सर.
ठीक है. भरत, डिड यू गेट माय पॉइंट?
यस सर, थोड़ा सा आया समझ में मेरे को। बट ये सेक का ग्राफ रहता है सर, ये तो माइनस इंफिनिटी जाता है।
हाँ, सो सेकंड का ग्राफ जब बनाओगे ना तुम, तो इट विल बी हमेशा ग्रेटर देन इक्वल टू 1. देखो ना, कोसाइन एक्स हमेशा क्या है, आप देखो कोसाइन एक्स का मॉड हमेशा क्या होता है, लेस देन इक्वल टू 1. तो 1 अपॉन कोसाइन, जो कि क्या हो जाएगा, सीकेंट एक्स का मॉड हमेशा क्या होगा बेटा, ग्रेटर देन इक्वल टू 1 ही है. अब सीकेंट
मॉड,
इनवर्स का मतलब
ओके।
क्या है, आप अंदर की तरफ वैल्यू देते हो और इधर एंगल आता है. जब वैल्यू जो है वो लेस देन 1 है, जब सीकेंट एक्स खुद ही ग्रेटर देन इक्वल टू 1 होता है, तो ये वैल्यू लेस देन 1 के कोरस्पॉन्डिंग में एंगल कभी नहीं देता. इट विल नेवर गिव यू एन एंगल. आंसर नॉट डिफाइंड. चलो इसको देखते हैं
ओके सर।
नेक्स्ट मीटिंग में, बिकॉज मीटिंग इज गेटिंग ओवर. सो नेक्स्ट मीटिंग वी आर गोइंग टू डू अ फ्यू मोर क्वेश्चंस ओवर इट. ओके.
ओके सर।
ओके बेटा.